Welcome to the Control Tower, everyone. I am your Exam Tower Director, and today we are running a full-scale, high-stakes emergency simulation for the Cambridge 9709 mathematics syllabus. We are tracking a massive, heavy tariff incoming aircraft on our radar grids today. It's Section 4.5, Power. Specifically, the absolutely relentless equation P equals W over T, which also equals F times V. Now, if you were sitting for the AS and A-level exams, this topic isn't a surprise. It's on your radar. It shows up in literally every single examination series. But today, we are not just doing a standard math review. Oh no. We are opening up the examiner's playbook. We're going to treat this like an air traffic control emergency, decoding exactly how the principal examiners manage the airspace, award the marks, and ensure you land your final grade safely on the runway without crashing under time pressure. So, look at your radar screen right now. Here is the ultimate anomaly. The elephant in the exam room, really. Why do candidates constantly drop marks on power questions when they know the aircraft is coming? They memorize the formula, they do the textbook exercises. But year after year, the examiner reports flash amber warning lights, showing massive point bleed on these exact questions. Why? Because students study the math, but they don't study the landing protocols. They don't understand how the principal examiners actually award the marks. It's like I always see with two types of exam students. Let's call them Router Alex and Router Sam. Alex gets totally bogged down in minor algebraic details, creating an infinite holding pattern and running out of time. Meanwhile, Sam rushes the arguments, trying to clear the answer for a landing way too fast, without actually verifying the structural safety regulations of the math. Knowing the formula is just having fuel in the tank. Knowing how to communicate your mathematical reasoning to the examiner is how you actually land the plane. To get everyone safely on the ground, here is our flight plan for today. 1. The core principles of power. 2. The technical methodology. 3. Securing essential method marks. And 4. Avoiding top examiner mistakes. Let's clear the runway. Moving right into Sector 1, Core Principles of Power, the theoretical architecture. Okay, listen up, because this is the structural entirety of your entire exam answer. The Cambridge Assessment Framework prioritizes analytical depth over superficial breadth. What does that mean for you in the control seat? It means you have to truly grasp the causal relationships here. Power isn't just some random letter P you write on a page. It is the exact rate at which work, W, is done over a period of time, T. And since we know that work is force multiplied by distance, and distance divided by time gives us velocity, we arrive at our secondary vector. Power equals force times velocity, or FV. The examiners are specifically testing if you understand this chain of causality. Think about it. If the driving force of an engine suddenly spikes, but the power output is maxed out and remains constant, what physically has to happen to the velocity? It has to drop. You need to systematically analyze these dynamic variables, not just blind plug numbers into your calculator like Router Sam would do. You have to verify the physical reality of the numbers you are dealing with. And look at this data point from the actual examiner reports. This is how the elite candidates operate. Candidates referencing cross-topic connections achieve significantly higher marks. In the 9709 syllabus, power does not fly solo. It doesn't exist in a vacuum. It is heavily networked with kinematics, Newton's laws of motion, and the work-energy principle. When you are analyzing an incoming problem, examiners are scanning your work to see if you can integrate P equals FV with these other sectors. Can you show how a change in kinetic energy over time perfectly translates to the mechanical power output of an engine? If you can seamlessly connect those dots using structured, logical reasoning, you are instantly signaling to the principal examiner that you are a top-tier candidate in full control of the airspace. Which brings us to Sector 2, the technical methodology, the standardized sequence. This is how we move from abstract theory to safe execution. If you want to manage extreme time pressure and prioritize high-yield marks, you cannot just wing it. You need a strict operating procedure. Examiners expect you to follow this exact standardized sequence every single time you engage a problem. Step 1. Identify key elements. Extract the raw data from the prompt. What is the mass, the incline angle, the friction? Step 2. Apply relevant principles. Lock in your theoretical framework. Step 3. Execute the analysis with crystal clear working. Step 4. Verify the results. This is where Router Sam always crashes. Do your numbers make physical sense? And Step 5. Present your final answer in the appropriate format. If you make this 5-step pre-flight checklist a habit, you will automatically structure your answers exactly the way the examiner's grading rubric demands. Let's talk about step 5 for a second, because presentation is your communication protocol with the tower. If you just scribble a chaotic, unstructured web of numbers all over the page, you are flying totally blind and throwing away massive points. You must deconstruct the problem and present your data following strict conventions. Use proper headings. Use the absolute correct terminology. Actually, scratch that. Don't just write F and assume the examiner knows what you mean. Is it the driving force? Is it the frictional force? Is it the component of weight down the slope? Specify it. Use appropriate formats for your units like watts or kilowatts, and provide clear annotations. Give the examiner a perfect glide slope right to your final answer. Make it impossibly easy for them to award you the marks. Now entering Sector 3, securing essential method marks. The insider's secret. Listen closely, because this is how we save your grade when the engines fail. Before we clear this next point for touchdown, tower transmission, check. Ensure your transponder is updated. Subscribe to Ace the Exams right now, hit that like button, and turn on all notifications so you never miss a briefing. Okay, back to the radar. I want you to burn this principal examiner warning into your brain. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. In Cambridge mathematics, a huge percentage of the total payload are method marks, the M marks on the scheme. These are given for simply applying the correct mathematical process, even if your arithmetic goes completely sideways under stress. Your clear notation is literally an emergency parachute. If you somehow calculate that 3 times 4 is 13, but your algebraic substitution into P equals FV was perfectly documented, you still capture the method marks. Show you're working every single time. To guarantee those method marks, especially when you hit a structural block mid-paragraph, you need to use the deconstruct, solve, evaluate framework. Think of it like formatting your approach vector. Elite candidates demonstrate evaluative thinking. They break the complex mechanics into highly logical steps. They solve systematically, and then, crucially, they evaluate. They check for reasonableness. If you are calculating the power of a standard bicyclist climbing a hill and your final answer is outputting the wattage of a nuclear submarine, you need to abort the landing and reevaluate. Justify your decisions with clear mathematical evidence at every step, and the examiner will have absolutely no choice but to give you those points. Finally, we are approaching Sector 4, avoiding top examiner mistakes, navigating the minefield. Let's look at the debris on the runway. I'm putting a 60-second visual timer on this concept because it is the single biggest reason students crash on this paper. It is the confusion between cause and effect. Listen to me. The cause is the actual, tangible physical force acting on the object, the engine thrust pushing a car forward, the friction and wind resistance pulling it back. That is the cause. The effect is the resulting velocity and the calculated power output observed. Router Alex always messes this up. Students will calculate power in watts and then mistakenly treat that power as a physical force vector pushing the object in their free body diagram. It is not. Power is just the rate at which work is being done by the actual forces. If you can keep that distinction crystal clear in your head, you will avoid the deadliest trap on the exam. So let's run the final emergency checklist, the top 3 principal examiner warnings. Number 1, as we just established, confusing cause and effect. Do not put power on your force diagram. Number 2, forgetting to check format and presentation. You lose the easiest marks imaginable because of missing units or chaotic, untraceable handwriting. And number 3, providing answers that are not specific to the given context. This is huge. If the exam context is a car moving up a 5-degree incline, your force equations absolutely must account for the component of the car's weight acting down the slope, mass times gravity times the sine of theta. If you ignore the specific contextual environment, your whole calculation goes off the radar. To manage all this under extreme exam pressure, here is a massive stress management memory hack. Encode the variables of P equals W over T equals FV into a vivid visual story. Imagine a massive, heavy cargo truck trying to climb a steep, winding mountain road in a storm. The literal driving force from the roaring engine is fighting against the physical friction of the mud and the heavy weight of the truck pulling it backward down the hill. That tension right there, that's your work and force. The sluggish speed at which it actually manages to crawl up the mountain, that's your velocity and time. Visualizing this physical reality completely grounds the abstract math. It gives you a real-world anchor to instantly recognize if your calculated vectors actually make sense. We are cleared for safe touchdown, but before you log off the radar console today, I have one final question for you. When you sit down to practice your past papers tonight, will your working be a chaotic jumble of numbers that crashes and burns, or will it be a clear, beautifully contextualized, step-by-step story that absolutely forces the principal examiner to award you maximum method marks. Keep that fuel to mark budget formula in mind as you prep. Do not forget to subscribe to Ace the Exams, enable that notification bell, and leave a comment down below sharing exactly which Cambridge math paper gives you the most anxiety so we can cover it next. Great work in the tower today, routers. See ya in the next simulation.